Hello everyone, welcome to my YouTube channel. Today we are going to learn chapter number 2 of class 10 Science Acid, Base and Salts. This chapter is very important for exams and daily life. Let's us start. What are acids? Acids are substances that produce hydrogen ions for H plus when dissolved in a water. For example of acid, hydrochloric acid, this is HCl, or sulfuric acid, H2SO4, nitric acid, HNO3, and common neutral acid for a less lemon contain citric acid and vinegar contain acetic acid. Acid taste sour. You can remember, see this equation: hydrochloric acid H plus and Cl minus. Here H plus is contain acid. When acid ionic compound are dissolved in water, the ions split apart from each other. This called the dissociation. You can remember. Most acid tests sour react many metals or one metals also to form H2 gas, are corrosive, appear to eat away materials while reacting. Okay, have a chemical formula also that begins at H plus metal plus hydrochloric acid. You can hear ZnCl2 reactions and example. This is the common acid: acetic acid, citric acid, formic acid, hydrochloric acid, sulfuric acid and nitric acid. All formula are very important for your exam. Okay, next, what is bases? Bases are substances that produce hydroxide ions OH minus in water. For example, sodium hydroxide, this is NaOH, or calcium hydroxide CaOH twice. Bases taste bitter and feel soapy when you touch. Okay, a base is substance that produce hydroxides ion OH minus when placed in water. Okay, this is when bases ionic compounds are dissolved in water, the ions split apart from each other. Dissociation, you can see this figure. Property of basic: taste bitter, feel slippery, are corrosive, or have a chemical formula that end with a OH. Okay. Next, common bases. This is ammonia, cleaners and a fertilizer also. Sodium hydroxide we can use in soaps and drain cleaners. Magnesium hydroxide in an ingredient found in antacid also. Okay. Next, indicators. Indicators are used to determine in a substance is an acid or a base. In an indicator changes a specific color when in the presence of an acid or a base. We can use here litmus also. First of all, we can how what are the alkalis? Alkalis are bases that dissolve in water. Okay, for example, sodium hydroxide, or alkali like potassium hydroxide also. All alkalis are bases, but not all bases are alkaline. You can remember carefully. Litmus paper. What is litmus paper? Indicator made of special filter paper that contains dye extract from lychees, the crusty stuff that ground in rocks. Okay, blue litmus turns into red in an acid, and red litmus turns to blue in a base. This is very important for your conclusion. Type of indicators: there is two type indicators, so are different colors in acidic and basic medium. Natural indicator: litmus paper red, cabbage is this example. Synthetic indicator, example is phenolphthalein, methyl orange, etc. Indicators giving a different orders also in acidic and basic medium. Uh, Olfactory indicators, that is onion and or a clove oil also. These are the metals react with acids. Zinc plus H2SO4, it gives ZnSO4 plus H2. Zinc plus HCl, it gives ZnCl2 plus H2. With basic zinc also NaOH and Zn2 Na2 ZnO twice H2 it gives. Okay, this is very useful in exam. This reaction are acids and base with metal carbonate and bicarbonate. This equation in your textbook is very important, so I did it. Na2CO3 plus 2HCl, it gives NaClH2 and carbon dioxide also. Okay, then next test for carbon dioxide. COH twice with carbon dioxide, we can calcium carbonate, this is insoluble in water, and add the H2O with carbon dioxide, we can get a calcium hydrocarbonate, this is soluble in water. Okay, reaction acid with base, you can remember neutralization reaction NaOH and HCl, this is made a salt plus water. This is very common and useful also in your exam. Okay, reaction in metallic oxide with acid, L2O3 plus 6HCl LCl, it gives LCl3 plus 3H2O. Zn oxide plus H2SO4, it gives ZnSO4 plus H2O. We can acid react with metal, we can get a salt and hydrogen gas. Metal carbonate with acid, it gives salt, water and carbon dioxide. For example, limestone react with acid and release carbon dioxide gas. Okay, you can remember this formula. And when the bases react with acid, for acid plus base, it gives salt and water. This reaction is called a neutralization. Or a non-metal oxides base react with acid oxide to form a salt and water. Okay, this is non-metallic oxide, carbon dioxide plus calcium hydroxide, we can use in this wall, coloring in the wall, whitewashing wall. This is carbon calcium carbonate and water is evaporate. pH, strength of acid and base is this called a pH scale. The pH scale is used to measure how acidic or a basic substance is. When the pH less than 7, this is acidic. pH is equal to 7, this is neutral or a pure water. Or pH is greater than 7, this is called bases. Lower pH means stronger acid and higher pH means stronger base. Okay, pH scale also help classify solution as acid or a base. pH is measured of the amount of H plus ions in a solution, potential hydrogen also. The more H plus ion, the lower the pH and the more acidic the solutions. Okay, this is your scale. You can remember milk, also baking soda, ammonia. Gastric contains vinegar, soft drinks also. This is very important. Next, when the describing acid and base strength and concentration do not mean the same thing. Strength means refer the ability of the acid base to dissociate in solution. pH measure this polar. Dissociation refer to the ability of an ionic compound to break apart into ion. And then next is concentration. What is concentration? It is referred to a amount of acid or a base dissolved in a solution. An acid or a base will have the same pH regardless how concentrated it is. Just because you add water to dilute it, it is still going to have the same amount of H plus ion. They will just be spread out or more. And here you can see strong and weak acids and base also. When the strong acid or a base dissolve in water, nearly all the acid or a base molecules will dissociate into ion. The greater the ability or to dissociate, the more potential the acids or base However, being dangerous because there are more ions available to react. When the weak acid or base dissolve in the water, only the small fractions of the acid or base molecules dissociate dissociate to partially. You can see in this all both figure also. With a less ion in solution, there is less potential for a danger because there are less ion available to react. Okay, this strong weak acid example. Strong and weak acid. First of all, strong acid is hydrochloric acid, stomach acid also we can call it. H2SO4 sulfuric acid, battery acid also we call. HNO3, this is nitric acid. Okay, weak acid is acetic acid or vinegar or a citric acid in a citrus food for a lemon and etc. Next, strong base, NaOH, sodium hydroxide. Second is any alkaline or alkali or alkaline earth metal with OH. These all are strong base. Weak base is aluminum hydroxide, often found in diodes. NH4OH. This is ammonium hydroxide, ammonia, used in many cleaning product also. What is neutralizations? Neutralization is a chemical reaction between an acid and base that takes place in the water solution. When the acid and base react, the H plus ions form the acid react with the OH ion form to base to form a HOH or we call H2O. It's a water. The overall pH become neutral. Okay. What is salt? Salt are formed when the acid react with the base. Hydrochloric acid plus sodium hydroxide. It gives sodium chloride. This is NaCl. This is common salt. And plus water we can give. Okay. You can see this here. We can use the salt is a compound that form when the negative ion from the acid combine with a positive ion form the base. Chemical for common salt, this is NaOH, caustic soda we can call calcium oxide chloride, this is a bleaching powder NHCO3, baking soda Na2CO3 plus 10H2O, this is called the washing soda also. First of all, preparation we can study. Preparation of NaOH, normal salt plus water and this chloralkali process electrolysis for in a brine solution. This we get NaOH or H2 and chlorine gas also. These both gases are very useful. Uses are here. Use of NaOH, this use of soaps and detergent, paper industry as a laboratory reagent. Uses of chlorine, these all are very important for your exam. Please listen carefully. As a disinfectants or making PVC, CFC or DDT. Uses of H2, hydrogenation of vegetable oil or as a fuel also we can use. Okay. Preparation of next second bleaching powder. What is formula of bleaching powder? CaOCl2. Okay. Chemical name is calcium oxychloride. COH twice plus Cl2, it gives CaOCl2, calcium oxychloride plus water. Use of this bleaching powder, textile industry for bleaching cotton and linen, paper industry for bleaching wood pulp, as a disinfectants we can use also. Next, third part is preparation of NaHCO3, sodium hydrogen carbonate. This is we call baking soda. Here common salt we can use NaCl plus water, ammonia gas and carbon dioxide. We get NHCO3 and NH4Cl also. Uses of baking soda and antacids, agent acidity against for acidity, sorry. In a soda acid fire extinguisher we can use along with edible acid like tartaric acid. In it's used for making breads and cakes soft and spongy. On heating the sodium hydrogen carbonate, we can collect Na2CO3, again say as Na2CO3 also. Okay, sodium carbonate, and we get water and carbon dioxide also. Here, washing soda Na2CO3 plus into 10H2O molecule, extra sodium carbonate decahydrate, we call this, prepared by restoration of the sodium carbonate. We call Na2CO3 plus 10H2, it gives Na2CO3 into 10H2O. Uses of this as a cleaning agent in a domestic purpose. Second is in the manufacturing of glass, soap, borax and paper also. Third is for removing permanent hardness also, we can use in this as water for crystallization. Water of crystallization is the fixed number of the water molecule chemically attached to each formula unit of the salt in its crystalline form. For example, blue colored copper sulfate crystals or a green color ferrous sulfate crystals also. We can use acid, base, and salt. Acid are used in batteries and industries. Base are used in soap and paper making. Salts are used in food, medicines, and constructions also. Next, plaster of Paris, calcium sulfite into half H2O, calcium sulfate hemihydrate. Half H2O, we call it hemihydrate. Two calcium sulfate units share one molecule of water. It is prepared by heating gypsum. It become hard on contact with a moisture. CaSO4 into half H2O plus 1 and half H2O, we can collect CaSO4 into 2H2O. Use of plaster of Paris for making decorative items, toys, making a surface smooth and supporting fractured bone also. Okay, in a hospital. Okay, thank you for summary. In this chapter we can learn what are the acid, base and salts, their properties and reaction, pH scale and its importance used in a daily life. Thank you for watching this video. If you found this video helpful, like, share and subscribe. See you in the next lesson.